Hello friends, let's ask ourselves a question today. Can a linear programming problem be solved using matrices? The answer is yes. I know a few of you might raise your eyebrows on this, but yes, it can be solved using matrices. It's a method generally not discussed. Can an LP be solved using matrices on calculator? The answer is again yes. Casio FX 991S, it has the capability of solving matrices and linear programming problems when expressed as a matrix can be solved using the calculator. So this is today's topic: linear programming demystified, matrix calculations on your calculator. Well, why should you be learning it? As you are all aware that when you make the simplex tableau, the LP solution requires a lot of row manipulations. And for a two variable, three constraint problem of LP, you require minimum 18 subtractions per iteration. So using calculators, matrix capabilities, well, to solve row manipulations, you can solve without row manipulations. Whenever you use calculators, matrix capabilities, you can solve the entire problem without using row manipulations. It's quick, definitely, and it's less prone to errors because you're not dealing with a lot of numbers. Once you put in the matrix, the calculator does everything. But yes, there's an alert here. With the current Casio FX 991 series, you can only maximum solve a 3 by 3 matrix. So our problem usually should be having three unknowns. That is, you can maximum have x1, x2, and x3, and you can have, since it can solve only a 3 by 3 matrix, you can have maximum 3 constraints. So 3 unknowns, 3 constraints. What we learn in today's lecture? Well, what is a matrix first of all? What is a matrix multiplication? I'll be briefly discussing it. And how to solve matrices on Casio FX 991S. Then how to write a linear programming problem in the matrix form. That is very important. Before we attempt to solve it on the calculator, we should know how to convert our linear programming problem into the matrix form. And then finally, how to solve the LP matrix on the calculator. To understand what is matrix, let us take up a system of linear equations. We have two equations, 2x1 plus x2 equal to 9 and x1 plus 4x2 equal to 7. In the matrix form, it is shown here. How would we write it? The matrix, the first matrix 2, 3, 1, 4 is the coefficient matrix. 9 and 7 is the constant matrix, and x1 and x2 are the unknowns. So the equivalent way of writing the system of linear equations as matrix is shown below. Now let's understand how do we multiply two matrices. We have two matrices here. A is 2, 3, 1, 4, and you have B. Now, if you want to multiply them in the calculator, how do we do it? So, in the Casio calculator that you have, click Mode and click 6. Now, let's enter matrix A. So, for this, press 1. And since it's a 2 by 2 matrix, select 5. Now enter the matrix. So we write 2 is equal to 3 is equal to 1 is equal to and 4 is equal to. This is the way we enter the matrix in the calculator. And then we click AC. Now to enter matrix B, once again, press Mode, press 6, and now press 2 to enter matrix B. Now this is also a 2 by 2 matrix. So press 5 and enter the matrix. That is 4 divided by 5 is the first element. Now the second element is minus 3 by 5. The third element is minus 1 by 5. And the fourth element is 2 divided by 5. Press AC, and now we have entered both the matrices in the calculator. To multiply them, press Shift and press 4. Now to call matrix A, we have to press 3. Multiplied by, again Shift, again 4, and this time we call matrix B. So we press 4 and we press is equal to. So now we have got the product of the two matrices, that is matrix A and matrix B, which is nothing but 1, 0, 0, 1. Now let's see how do we use matrix multiplications in the calculator to find the solution for a system of linear equations. The system of linear equation is 2x1 plus 3x2 equal to 9 and x1 plus 4x2 is equal to 7. So equivalently in matrices, it has been represented as 2, 3, 1, 4, x1, x2 equal to 9, 7. Or in a very short way, it is written as ax into b. The solution is found by pre-multiplying the left-hand side and the right-hand side by the inverse of a. So now let's do it. Before we start any fresh calculation, you should always go to mode 1 to remove all the previously entered matrices. Now let's go and enter matrix A. So that's going to be mode 6, 1 and 5 for a 2 by 2 matrix, and we enter the matrix, that is 2, 3, 1, 4. Now to enter matrix B, we go to mode, we go to 6, and this time we select 3, that is matrix C. So we press 3 and we select 2 by 1. So that's 6, and we enter the matrix, that is 9 and 7. We are done. Now to get the answers, we have to take the inverse of matrix A. So we press 3 and take the inverse of it and multiply it by matrix B, which is nothing but matrix C in the calculator. So multiplied by Shift 4, 5. And we have our answer, that is 3 and 1. Let's check that. The answer indeed is 3 and 1. Now let's learn how to use whatever we have learned so far about finding the solution for a system of linear equations and matrix multiplication to solve a linear programming problem. The LP problem given to us is z is equal to x1 plus 2x2, subject to the constraints x1 less than equal to 2, x2 less than equal to 2, and x1 plus x2 less than equal to 3. Now, of course, the solution should be that x1 and x2 both should be greater than 0. That is, both the variables cannot have negative, or either of the variables cannot have a negative answer. Now, how do we solve this linear programming problem using the calculator? For this, we will have to convert the constraints to equalities. Well, there we are. You have to now maximize z is equal to x1 plus 2x2 subject to the equations x1 plus s3, where s3 is nothing but the slack variable equal to 2, x2 plus s4 equal to 2, and x1 plus x2 plus s5 equal to 3, where s3, s4 and s5 are nothing but the slack variables. And of course, The objective function is now rewritten as z is equal to minus 1 x1 minus 2 x2 equal to 0. Now we construct the simplex tableau where in the first column we have the basic variables and on the first row we have the variables. So the basic variables now are S3, S4 and S5, and of course this is the variables, and here we have in the last column we have the RHS. The RHS is 2, 2, 3, and now here we note down the coefficients. So the coefficient of x1 in z is of course minus 1, x2 it is minus 2, and the rest are 0. For equation number 1, the coefficient of x1 is 1 and the coefficient of s3 is also 1. The RHS is 2. For equation number 2, the coefficient of x1 is 0 but x2 is 1. S4 also it is 1 and the RHS is 2. And for the last equation, that is the third equation, the coefficient of x1 is 1, the coefficient of x2 is also 1 and the RHS is 3. Again, the basic variables are S3, S4 and S5. Now the entering basic variable in this problem is found out by knowing what is the maximum negative entry in the first row. Now the maximum negative entry is minus 2. So this is known as x2 is known as the entering basic variable. This entering basic variable will replace one of these three variables. So let's start with the first iteration. X2 is the entering basic variable. Now how do we decide what is going to be the leaving basic variable? We will look at the coefficients under x2 and we will also look at the RHS. We divide the RHS with the corresponding entering basic variable coefficient. That is 0 divided by 2, that makes it infinity. 2 divided by 1, that makes it 2. And 3 divided by 1, that makes it 3. After this division, we find what is the least ratio. The least ratio, of course, is 2 divided by 1. So S4 will be the leaving basic variable. So the entering basic variable is x2 and the leaving basic variable is S4. Now we construct matrix B, where matrix B has all the columns of the basic variables. Now the basic variables in this case is S3, X2 and S5. Let's go back. S3 has 1, 0, 0 as the coefficient. S5 has 0, 0, 1 and X2 has 0, 1, 1. There we have noted it. So let's enter this. We select matrix B and it's 3 by 3. Now we go ahead and enter it. So 1, 0, 0, 0, 1, 0 and 0, 1 and 1. We are done. Now let's enter matrix A and C and B. Of course, in this we will only enter A and B in the calculator. The matrix C is nothing but the coefficient of x1 and x2. Now the good thing here is that the matrix A, C and B will remain constant throughout the calculations. We will only have to update matrix B and matrix C. So let's enter it. Now the matrix A, we should enter it. So that's going to be 6 and that's going to be 1. And of course, matrix A is going to be 2 by 3. So that's, sorry, 3 by 2, that is 3 rows and 2 columns. So we select 2 and we enter it. 1, 0, 0, 1 and 1 and 1. Now we are pretty much done with entering matrix A. To check what are the matrices stored in the calculator, you just press shift and let's check matrix A. So we press 4 and we click 3 and we click equal to. So we get back the matrix. Now shift 4 will give you matrix B back. So a quick check, yes. Now we are only left with entering matrix B, that is 2, 2, 3. So 4, that is 6 and 3. And of course, this is 3 by 1. So this is 3 and we enter it 2, 2 and 3. So matrix A, B and small b, which is nothing but matrix C, now has been entered. Now, of course, after the first iteration, what is the value of the coefficients of the objective function is given by this equation. That is, the first coefficient is given by CB into B inverse into A minus C. The second coefficient is CB into B inverse into A minus C. The third, fourth and fifth coefficients are given by CB into B inverse, and the value of objective function after the first iteration is given by CB into B inverse into B. Now, what is CB? CB is nothing but the coefficients of the basic variables in the objective function. The basic variables, as you remember, were S3, X2 and S5. Now, the coefficient of that in the objective function is 0, 2 and 0. So now we find out B inverse into A. So for this, press shift, press 4, inverse into shift 4 and 3. There we have B inverse into A. I have already noted it down for you. The B inverse is found by shift 4, inverse, and there you have the B inverse. And B inverse into B is going to be nothing but B inverse multiplied by matrix C. To find this, we press shift 4, that is we call matrix B, B inverse multiplied by shift 4 and small b is nothing but matrix C. So we click 5. And there we have it. 2, 1, 1 is nothing but B inverse into B. Now the first two coefficients, as said earlier, was found by CB into B inverse into A minus C. So CB is 0 to 0 multiplied by 1, 0, 0, 1, 1, 0, that is B inverse into A minus 1, 2. Now I have done the calculation for you and you can find it. It's minus 1 and 0. Remember, we cannot multiply 1 into 3 matrix in Casio calculator. I can show you mode 6. And let's select matrix A itself. So 1, we do not have 1 by 3 matrix to be entered in the calculator. It doesn't allow you. So we cannot perform this multiplication. To do this multiplication, we have to do it manually. So it's very simple. It's 0 to 0 multiplied by the first column. That is 1, 0, 1. So that's going to be 0 into 1, 2 into 0 and 0 into 1. So that's 0. And similarly, the second element is found by 0 into 0, 2 into 1 and 0 into 0. That is 2. So 0 into 2 minus 1 into 2 makes it minus 1 into 0. Now we find the next three coefficients of the objective function. For that, they are given by CB into B inverse. That is, CB, as you already know, is 0, 2, 0, and B inverse is something we have already found using the calculator. So that's going to be 0, 2, 0, right? So the updated simplex table is now on your screen, where the coefficients of x1 till s5 is going to be -1, 0, 0, 2, 0. And of course, the updated basic variables are now s3, x2, and s5. And the coefficients for this is given under x1 and x2. That is, the coefficient of x1 and x2 is now given by B inverse into A. And the coefficients for S3, S4, and S5 are given by B inverse. And of course, the RHS, that is the updated right hand side, now is going to be B is equal to B inverse into A, which we already found out was 2, 1, and 1. Of course, do we have to do further iterations? The answer is yes. So we have to start with the second iteration. Now the highest negative entry is under x1. So this is now going to be the basic variable which is going to enter. This is going to be the entering basic variable, and the leaving basic variable is now going to be S5, because the ratio of 1 divided by 1 is the lowest. So now we have the updated B. So now the B is going to be the columns under S3, X2, and S1. Now all we have to do is just update B to do this calculation. So for updating, what we do is we go to mode, we go to 6, and we go to 2, and we go to 1. Now we have to update it. So we come here, we enter 1, and again scroll, we enter 0. It's already there, but still enter 0. And then, of course, come to the last one, and it is 1, right? And it's already 1, so it's okay. So we have now updated it. Now, of course, remember, A, B, and C, they remain unchanged in the iteration. So the updated values of Z are again given by the same equation, which I had already shown a few slides back. And the value of Z, that is the objective function, is given by CB into B inverse into B. So now CB is going to be the coefficients of the basic variables in the objective function. Now this time it will be 0, 2, 1. Now why? The basic variables now are S3, X2, and X1. Now the coefficients of S3 are 0, that of X2 is 2, and that of x1 is 1. And B inverse into A, let's find it out. What is going to be the fresh B inverse into A now? This is going to be shift 4 inverse into shift 4 3. There you are. It is 0, 0, 0, 1, and 1, 0. So we have it. Now B inverse is shift 4 inverse. Now this is your real updated B inverse, that is 1, 1, minus 1, 0, 1, 0, and 0, minus 1, 1. And the updated RHS now is going to be B inverse into B, which I think you can do it by now. So this is going to be 1, 2, 1. Try it out for yourselves. Now the Z is going to be 0, 0, 0, 1, 1. I have calculated the coefficients. You already know how to do it. I have demonstrated it 3 slides earlier. So you know how to calculate now the updated coefficients of Z. What do you find? The updated coefficients of Z, the first one is nothing but CB into B inverse A minus C. Okay. So this is nothing but it is going to be 0. So 0, 0, 0, 1, and 1. Now we see that we need not do any further iterations, okay, because none of the coefficients are 0. So we go ahead with finding out the value of the objective function, which is going to be nothing but CB into B inverse B, which is nothing but 0 to 1 into 1 to 1, right? And that is fine. Now 1 to 1 is B inverse into B, as you know, okay? So that's it here. And the value is now going to be Z is equal to 5. And to find the value of the basic variables, that is S3, X2 and X1, it is not going to be nothing but this is going to be equal to B. So S3 is 1, X2 is 2 and X1 is 1. So just remember one thing, once you get a hang of this method, it is error free. Now here you have not even done a single subtraction or row manipulation. No row eliminations have been done. So this makes this method absolutely error free. And once you get an idea of it, it's going to be pretty simple. Remember one thing, once again, why would I motivate you to learn this method is for each iteration, we have done 2 iterations here. If you had done the original simplex tableau method where row eliminations were involved, for each iterations, you would have to do 18 subtractions. Now, the chances there of doing any mistake is pretty high. So that's the end. If you like this video, do forward it to your friends. If you have any doubts, do write it in the comments. I would be happy to clarify it out. Please like and subscribe my videos. That motivates me a lot. Goodbye, friends. Have a great day and have a great time too.